Hello, good evening, good afternoon, wherever you are joining. So thanks for joining us. Today we are going to give the session on Prometheus and Grafana using Azure. So today with us, Vishwas is here and he's really researching on Prometheus and Grafana, and he's going to share whatever he has researched till now. And I think it's going to be a great session because he is also learning and he's going to share what he has learned with you all. So without further ado, I'll just hand over the session to Vishwas. Vishwas, welcome.
Thank you so much, Deepak. Thank you so much. Yeah, folks, I think you can see my screen. That's fine. You can see my
Yeah,
screen,
we
right?
can see. Yeah. Yes, we can see.
So, so we have seen how the Docker works. We have seen how it's really brought the transition from VM to the containerized applications. Then we had something called as microservices, which were like chunks and chunks of the all features, which was just made into chunks, and now collaboratively they were made into one piece, and afterwards you were all ready to just hop in and do all sort of work with it, right? So Kubernetes has its own way of orchestrating the way in which the containers work in such a way that I can show you one of the boards here. Like, it's a black board, so do bear with me for a while. So it's a simple application. It's nothing that complex. It's not that simple as well, because there is a lot of complexity which were being solved and which were being addressed over a course of time. So it's a simple diagram that I've drawn. This is what your kubectl does, your kubectl commands and kubectl uh, references, all these what you talk today about the Kubernetes. This is what your control plane, control manager, schedulers, and the file system which is being taken care by the containers is always still here. And also, when you go for an view which is like an not that superficial but yet more effective, this is how it looks like. So this is a pod, there is a container runtime, there is a kubelet, there is a system service which is controlling all your container runtime, kubelets, and everything that you see here will now be a pod. And all the things will be segregated as a node, and there will be a load balancer which will be communicating to and fro with your uh, application, whether it's containerized or a serverless application. You still have this kind of an leverage that you can build. Serverless doesn't mean that okay, there is no server. Servers are still there. And how industry makes a leverage out of it, that's what we'll be talking right now. So of course there are a lot of companies which still uses it. If you want, you can actually go to HBO and Kubernetes on YouTube. They still have a good case study on all their applications and all their use cases, and you guys can see that. And I feel like Adidas is doing pretty great. Adidas also has Azure here, so don't worry about that. And a lot of other companies like Hotstar. When you see on Hotstar, it marked an history all of the sudden because there was a rapid increase in the one. So if you go here in the Google tsunami Hotstar, you just type this, all the systems and everything. Like, this is all what you see, right? Uh, Hotstar servers, or else do something scaling the tsunami transform and the things like that. You know, when you see all these kinds of graph, right? This really brings me a lot of joy about like how privileged we are to be born in this era. And this is an amazing article. Do read this. Do check this out. This is an amazing article. I wish you all read this article because a lot of times when you are thinking of okay, only this is what my application should look like, it's not that. It's beyond it. So if you see, there is Kubernetes everywhere. But I'll show you some of the architecture. This is your storage system. This doesn't have the Kubernetes. This is a theater ticketing system. Doesn't have any sort of stupidity like Kubernetes. And I feel Netflix should be addressed because Netflix marked the history of DevOps. Netflix. whenever you see, just pause it. If you are seeing over a course of time, just pause it and just come back. There is no Kubernetes at all, because I haven't, when you think of the past 5 years, there is no thing called as, why are we not able to scale or something? Why do you pay money for a cloud service provider when you want to think of what to scale, what not to be scaled, right? So this is what it is. So this article primarily talks about scaling, but it's all about observability, like a lot of data points which are coming in and out. How are we scaling it for the chaos and things like that? So what we will be doing is, we'll be just doing probably 0.0001% of what industry has offered for their systems itself, but at the end of the day, we'll just make sure that we know something. So if you think of Dynatrace is accelerating their customer growth through Azure. Like in the backend, it's all like, of course, Dynatrace is used by AWS, GCP, Azure for the observability platform. Because what we'll be talking is a kind of observability and monitoring and things like that. And what is observability and monitoring? It's very simple. Where is the board? Yes, it's here. So what do you have in a code base, like something like oh, sorry, I should go for other. And what do you have in a cloud based function is an indented function, which looks like this, like this, like this. There'll be break, or else an exit, or else anything. Like there will be some strategy for you to get out. It will be C++. Sorry. It will be C++. It's taking C++, Python, or else a Java application that you will be running, something like Spring Boot, or else anything which is actually controlling how the data flows in and out from the front end and the back end, and all these things, right? So this is what brings the complexity all about. Like something like, okay, something like I missed a semicolon and I spent 3 hours on searching it. Like today it doesn't happen, but like there are olden days where people used to think, okay, I missed a semicolon, where did I miss the semicolon, and the things like that. And it gets complex because C++ can be used for drivers. Your all right, so I'll write something and I'll change the text of it. So that will be awesome. So your Python will have some sort of a backend where it will be now communicating with a DB. Now it will also be communicating with an function app. It doesn't matter whether it's AWS Lambda, Azure functions, or else Google functions. Everything has its own way of working. So you need not have to say that I'm going to work on this, I'm going to work on that. Anything is fine as long as your applications are not broken. That's fine. That's applicable. So there's a driver which will be written using something, or else there will be some sort of an geek who writes some Spring Boot application, whatever it is. Like it can be something like an MVC for something, or else a package, whatever it is. So in a meanwhile, when you look at the DevOps process, it's something like there is dev, there is test, and when you think of something like this, there is something called a stage. But between that, there can be a QA. Between that, there can be any person. But all of it is connected to one component, that is your GitHub. So that is your VC, anything. It can be anything which can be having a lot of codes. But all of this need not have to have the same level of functionality or anything. It can differ over a course of time. So you can have a graph which is as cool as this, which is like constant performance like every time. But what if your customer line turns out like this, and it goes up like this, it comes back and things like that? So this is just an arbitrary graph that I'm saying. Let me just say, okay, you are a stock broker, you're a stock market firm, something like that, and somebody says that your company is broke and everybody wants to come back and take off the shares from your company, or anything, any sort of situation. What if at this situation you've found that, okay, your time, and this is the performance, so this is the people, and this will still be the time. So what if you have something like this and all of a sudden your performance goes down? So anything can happen. So what all these are is like something like, okay, we have Kubernetes to scale, but do we have an automated way of testing what if something goes wrong? They say auto scaling, this, that, nothing. It's just the process of understanding what your system can do. So whatever you are seeing here is just a set of data points. So all these data points, what you are seeing has an story. All right. So if you think of something as a story of chaos and story of privilege, because you should also be thankful that a programmer wrote something like that, story of privilege. Like something like today we had a talk like, okay, Vivek sir told like we had a rule that no deployment on Friday, but even on Saturdays and Sundays he was there with some production issues. So in the meanwhile, you can't really control the fact that it's an organization filled with a lot of people, lot of technologies. There's moving parts, like something like today I'll be working on computer vision model deployment. Tomorrow I'll be working on an Angular front end, which might make my model that is deployed yesterday look even more appealing and people start using. So there are ways in which customer interact with, like something like, okay, something like DDoS attack. Every system is DDoSable today because we have a lot of complexity in DevOps itself. And per se, we had a lot of complexity on the other platforms as well. So it doesn't make sense until and unless we know what is our data points and things like that. So I think let me just go back to the storyboard. It's a simple, actually, it's a stupid one. Like I just drew it because had a lot of time and I had a lot of patience to spend. And yeah, I think where is my, oh right, that's a Terrascan. Forget the fact that it exists. So the storyboard is something like this. It's like you have deployed somebody and very good microservice application, and now you have a customer who says, "I have a broken system." In earlier days when you talk with the DevOps guys, it's all about something like, hey man, we didn't have something called as DevOps. It was all system admin, system engineering job and things like that. Today we call it as Dev and Ops. And I think if you see some articles, it's oh, sorry for that. It's a star Dev, star Ops, and it's star. If you want to really know what's the biggest motivation it is, it's Ben Rockwood. All right. Oh, my X is broken. No, 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 no. I had that. Okay. So I saw one of his talks on DevOps. It's called as DevOps transformation. And I felt really proud because I'm an ECE student, and most of the people that he mentioned there were some sort of an ECE students. And if you want, I can even show you that article as well. So don't worry about that. So star dev, star ops. Oh, sorry. Star ops, star. It's for the logging information and the things like that. So mainly there is a lot of biases which will always be talking about. Wait, I can even show you Ben Rockwood, one of the amazing professionals. Where is his DevOps transformation? So that's there. Where are you? The smart OS is also amazing talk. Actually, you have to see that, but wait, I'll go to that. Ben Rockwood, Word DevOps transformation. So yes, This is the best talk that you can really go back and see, because a lot of things are here, a lot of articles, a lot of scientists, a lot of TQM people. Like, he has a different perspective. Instead of buying a book on system administration, system engineering, go and buy a book on OM, which is operations management, because it's a kind of a subject which these people have looked forward to, and they have started analyzing it, and it all talks about this only. So whatever I talked about, Ben Rockwood talks about this, and the operations management talk about that. If you want a serious MBA guy, I'm not the guy. Sorry for that. I'm not a marketeer. I'm never going to be a marketeer because I'm very bad in talking. So Professor B. Mahadevan, one of the best profs in the world. Like, I fell in love with Bhagavad Gita and all these things. So management and Bhagavad Gita paradigm, all these things are there. And I think I can share some of my podcast, because in that podcast they have talked about logging, monitoring, and all these things. So yeah, I think Vandana Vama was great. I think you guys can go check that. But I would say this is the one that I would suggest you: 73, 74, 75, 70, 69, and whatnot. 67, Nilesh Gude, he was an amazing person. Prashant Echan. Like, just listen to my podcast series. You'll get to know what is going on with it. And I think Prometheus. Sorry, I didn't want to. I just wanted to look whether there are some case studies on Prometheus, but no. But Dynatrace uses it. Iguazio, the CTO of that company, came and gave a talk in our session, which is on ML Run, ML Ops, and things like that. So you guys can check that. They are doing pretty great in terms of their research and whatnot, man. They're doing pretty great. And I think that's it from the theoretical point. I think let's just go to my Chrome, because I wanted to show you what is this autoscaling all about. So by the definition, it's always something like the quick ship software faster than ever before. But what happens when you build it? So benefits of autoscaling. So it's like 24/7 production. What if it goes down with a probability of 0.01% being true? And all the things about setting the auto scaling and all these are still here. So this, by the fact, is something like a KEDA and auto scaling parts and all these. So if you want to know what is this KEDA, I think Vivek sir did a session on KEDA. I don't know, it's in Reactor or somewhere else. KEDA, Vivek Sridhar. Yeah, this is the one. This is the one. Perfect. Yeah, this is the one. He did it on KEDA and Kubernetes event-driven autoscaler. So you guys can think about all these things, because today we are talking a very big thing about data mesh. It's like service mesh was there, but like, what if the same old data lakes become obsolete tomorrow, because tons and tons of data, right? So that's what it is. So auto scaling, do suggest that. I just love you guys to read it, because this is actually a pretty good one if you want to really understand what is this auto scaling and all about. Don't do all the commands also, don't do anything, just go there, just read it off. Like, this is also great. And Kubernetes health monitoring, why is this required, what is this required, because there is a lot of other stuff. So all the things that I'll be talking here will be coming through this block diagram that I'll be talking through. So I'll not go through and pour you all these. So this is automated and things like that. So fine. So all of this is good. So if you want much more of an automation, today's IAC world, infrastructure as a code. So make sure that you understand what is this Terraform. On the other side, it's there is more side of and DSLs. So it's called as domain specific language and the things like that. You guys can go there. And I wanted to do Helm, but I thought to myself, okay, just showing them how to do this Prometheus is a big task, because Helm is, there's containers, there's Kubernetes, and there's a little bit of automation that I do with Jenkins. And why to waste time? Because Jenkins session is there next week, so let's just do that. And also, I'll be teaching you how to do this queries and things like that. But I actually refer to this article. This is actually from from Alexander. I think he's a Russian, but I can't spell his name. Sorry for that. And amazing way, because they have written everything that is required for you, and also I'll show you how the graphs looks like. How does the graph look like? All right, why does this come up? All right, nine, 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 nine. No, 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 no. All right, so this is how your graphs looks like, and if you go back here and if you look at all these byte sizes and all the things that we are talking around, like, so all these have their own charm in the industry. So you need not have to worry about it. So all these graphs that I'm talking here, I'll be explaining you what it is. So wait, not that, not this. I think this is perfect. I think we can do this. All right, this is not the best way to do that. Hey, why did this come up? Because it should actually come up with a lot of ease, but it didn't come up. All right. Why did this come up like this? Oh, fine. So wait, there are other commands as well. So there it is. So if you can think of something as a graph, it can be as good as this as well. So if you take the area graph, it's like this. The bar graph, it's like this. And there was one more, I forgot that. Wait, it's no, so it's not 7 days. I don't want 7 days data to be analyzed, because today I just bought in this Kubernetes cluster. I'm just showing you, so don't worry about that. All right, where is this? I want something else. So this doesn't work. I'll say you why, but let's see if this works out. Because it's been a long time since I've been running this container. So, not the container, Kubernetes cluster I'm talking about. So, yeah. So it talks about the instance, perfect. All right, fail to fetch. That's okay. That's not a big deal. So when you ever look at it, so there is a node exporter, there are all these things. So this is just an abrupt introduction that I wanted to give, because a lot of times it's not that complex, but we tend to make it complex. So that's what I wanted to address today. So all these, oh man, come on, it is not taking too much time. I think so. Yeah, 8060 is working. 8020 is also working absolutely fine. All right. 8060 has no error. That's perfect. So all the things that I'm doing here will be just shown to you. Don't worry about that. So yes, example, sample, height samplers, show samplers, and there are a lot of things, man. Meanwhile, you can also think of this. So it's just an intro. So let's just hop into whatever it is. So yes. So what I wanted to show you was a cluster configuration. How are we doing this RBAC authorizations and things like that? So in a Prometheus, whatever you are seeing about this RBAC authorizations, everything is always an block diagram. So what you're doing is just a chunk of it, but in the back end, there is hundreds of codes which are running there. So config maps are actually doing a lot of configs. So why I wanted to show you all these files and the graph before, it's because that has a lot of things to be said. So that's what it is. So this is new file Grafana. Oh, this is not yet created or working, because I wanted to work on that completely, but Prometheus had a lot of Grafana installed. So There's already an inbuilt function which is already there, and already there is an API which is already running on behalf of that. So why to waste it? So it's an Prometheus service or 9090 service. Node port is 30,000, and all these. So we'll discuss what is this all about. Fine, where are you? This is perfect. It doesn't have to break now. So I hope it's visible. So don't worry about this. This actually should go out, but it doesn't go. So what it is, just analyzing is there are some short-lived jobs. Like there is this container instance that I actually built. That is this. No, wait. This is namespaces and everything will just come apart. So there is this kubectl version. So this is one of the container which is running this, and the other container is from another portal which is this. So helm chart demo. I wanted to do an helm chart demo, but I told like, okay, this is going to be a little complex, but I use it for namespace analysis and things like that. So Choco install Kubernetes Helm. It will get installed. So further process in the next session. So there are some short-lived jobs, and it has some push notification. And these are some push matrices which actually say, okay, this is what my system is today, and what next. What is it just going to do is it has a lot of Prometheus server. Prometheus server is what I showed you there. The same old local host. It's not a local host because it's not 000, it's 001. So it's not a local host at the end of the day. And what it's saying is, okay, there is a server. So there is a pull matrices. So let's just analyze what is this push gateway going to give me now, and what is this Prometheus targets. That is like jobs and exporter. That means like where is my target sitting? How should I analyze it? And what should be my process in order to do that? So that is what it is. And afterwards, you have a cloud managed cluster, which is from Kubernetes. You can go for, yeah, Azure, AKS, Azure, AWS, which is EKS, Elastic Kubernetes Services, which is GKE, Google Kubernetes Engine. So all of these, they just have Kubernetes configured, and they're just managed by your cloud service provider. If something goes down, like version control, this, that, and all the things, you need not have to worry. He has to worry about it because it's his own hardware. But what you're paying is for what you are using. So that's what it is. And I think it costs because it costed me a lot. Google Slides. It costed me 800 rupees because for my federated learning paper or the project that we have taken, it's a personal project that I am doing. So wait, it should be somewhere here because I think it in this is one of the DDoS example that I wanted to give. That's a different one, but I think yes, this is the one. It costs. It really costs you. Like it costed me around like which was around like AKS agent pool, node pool, and other things. Like it cost me. It cost me a lot. It costed me a lot of money. So it will cost because it's always managed. It's always done. If you have too much of patience, then just go on, wait for a year, just get the matrices. But your Kubernetes services are already there, so why to waste it? So that's what it is all about. So service discovery is from some sort of an file st set. There is always that Prometheus file which is always being configured. So that is what your file st set. Local system service discovery is all about. So discovery of the target is always from the retrieval system which is always there. So TSDB, I'll be showing what is that on the UI board itself. So don't worry. So what you are seeing is an HTTP server which is receiving all the graphs, the client request, the Prometheus web UI is interacting with it, and the things like that. So PagerDuty is one of a SaaS application which really gives you a leverage for in taking in messages from any sort of app. If you are very bad at targeting all these kind of SaaS applications or something, what you can really do is you can just get it on Slack. Slack really works absolutely fine. If it doesn't, no matter what, just throw it off to some other application. So that's what it is. So I'll be showing you a quick thing, and I'll also be going out with the commands as well. So don't worry on that. So there's an help. Oh, This goes to the documentation. That is fine. Let's not touch that. So TSDB status. What is this TSDB? Let's just go to the Google and type that TSDB in Prometheus. It's one of the file system which storages a lot of resources for what is your application going to be. And if you want to configure, this is how your file systems looks like. This is just a tree which is there. Like I'll even show you how. So if you just do tree for listening path, so no subfolders and things like that. So let me just do this dir this config maps readme, and the what you are seeing is this. So what I can do is cd dot see a tree file listings and volume is cd. Okay, fine, let's not do that. So cd Kubernetes Prometheus. So if I do dir, it works fine. So it's very simple. What I did was, I'm too lazy to configure all the Kubernetes because it takes time on a local system. What I did was, I went to the portal. I had a Kubernetes services which is running out there. So I clicked on it, or else you can type in Kubernetes. Oh, sorry. You can type in Kubernetes here. If some it pops up, Azure Arc probably. I'll do it in November. Don't worry. So there are a lot of other my cluster. This I created using the command line. So I'll be even showing you that there is a DNS name which is already attached to it. I tried doing a cluster, it didn't come up. So there will be a DNS name. Why I wanted to show that? Because it's all unique. It's a unique resource for you. So that's what I wanted to show. So there is a cluster. So I created one. I just typed in all the things. So whatever you see is simple, and it takes time, and it says go to resource and things like that. So what you can do is Vishwas group, it already came in. So I hope you guys can see that it's in a standard demo. It's saying availability zone. What does an availability zone mean? Zone in Azure. If you think of this, what if your Kubernetes cluster start breaking and your server is not present? So what it does is, there are different regions within a space, and what it does is, there are different regions 1 2 3, which is for the fault tolerant mechanism. It just goes and asks the server to virtually create a new cluster for you, and it will just keep your application up and running. So this is what your resources mean. And later, if you go for all that, it's a thing. So I just created that. I click on the review, it does, and afterwards I just created, it does, and the next moment, what I'll be having is this. So I don't want it to be created because already I've created a lot. Just get in, just press on this click but connect button. It gives you all the commands. If you are a script head, just go start typing the commands. So what I did is AKS get credentials, resource group, what it had, and help chart. It already created. Or else, if you're a script head, you can really go here. Wait, it's here. So you can really go ahead and type in all these commands. I made some error, so I know that I made a lot of error, but I wanted to show you something also. So AZ group create my registry. My registry was already created, and West US had an issue. Fine. So what it did is, my registry was created, and ACR create my registry. My resource group was not even there. So I even did that. But in a meanwhile, I had created this my registry, my cluster. All of these had a DNS name. So it was impossible for me to create any of it. So I just created using another name, which is Vishwas and things like that. So it started working. And when you look at all these resources and things like that, so it's all there for you to analyze. Okay, this is what my resource group is all about, this is what I need, this is what they need. And your DNS name has its own way of working, so don't worry about that. All right, so what is this? Perfect. Then when you think of all these, it's still the same thing. So what I want to do is I just remove that application. So I'm in that demo where I'm just going here. So what I do is I want to show you what is this name all about. So I have a cluster role.yaml, I have a config map.yaml, Prometheus deployment.yaml. I think this is perfect. Yes, this is perfect. And there is Prometheus Ingress. I wanted to do that, but Prometheus Ingress is also another session on its own. Ingress is nothing but it's basically for the security of your system. That's it. So you can map to some or the other URL. You will not be having that public URL given to everybody. So it will be something like you are mapping it to something else. So Prometheus services and the things like that. So I'll share what these files are. So it's all the same file, YAML files, two spaces for indenting the resources, and it's there for you. So what I have is a metadata Prometheus service. It's a namespace on monitoring, because I have a namespace called as monitoring, and I'll show you what it is also. So if you think of what is namespace, it's something like a virtual resource for your entire deployment. Like something like you have an Kubernetes cluster, which is absolutely fine. So there is AKS. All right. क्या हो गए? AKS. And inside it, you want to deploy some more application. So what you do is you AKS with a namespace, AKSN is what I really wanted to call. Inside, it works as good as what it works here also. So I'll be showing you that as well. So wait. Oh my god, where is this? Kubectl create minus namespace. It's here. So reconnect. Perfect. I did it. It's reconnecting. So if I do kubectl namespaces, or else I can even show you here. So it's better that I show you here as well. So if you go here in the Kubernetes resources, you have workloads, service, and the ingresses. What I told about the ingresses is like mapping to one or the other thing. So filter type and ingresses, and what are these? So there is a Kubernetes UI.example.com, like what I told you about mapping to one or the other UI or something. So this is what your UI looks like. So there are a lot of YAMLs here. So whatever I did on the namespace monitoring, there is creation time, there is Prometheus, this and that. Like, don't worry about that. It's always that same old YAML that we are talking now. So kind ingress, so Prometheus UI and whatnot. So which verse is here? So storage is what we talked there. So storage is also being talked here. So namespaces. Very simple. You just have this command here. You just create it, done. So a simple command for that is commands dot create namespace monitoring. So if you do this, I'll show you how it's in the demo as well. So if you do this here, I think I minimized it, but I don't know. It's connecting. Let it connect for a while. Or else, are there any open terminals? Arey man. Wait. Since I have this, I'll even show you what is this. So I'll do monitoring one. I'll even show you how this will be created. So this was created with respect to, wait, Prometheus demo, that is fine. Whoa. Let's see where it has got created. I think probably this was the first one that I created. So I think monitoring one has been created here. So 26 seconds ago, I created this monitoring one. So whatever I did here, it got affected here. So it's like you having your localized Kubernetes cluster as well, but it's working globally too. So that's what it is. So direct Kubernetes. So what you are seeing is a cluster IP that is inside the Kubernetes cluster. Outside, to access it, you need this IP. So it's always protected. So that's what your Kubernetes security is all about. So very simple. So all right, not this, not this. So there are hundreds of services. So let's just go there. So describe services. So Azure vote back and whatnot. All these external IPs and all these endpoints. everything has been created here. So if you, I hope this endpoint doesn't come up because this is in Kubernetes one. If my client sent HTTP request to an HTTP server, perfect. It's not accessing my what app, which is this. I think this. Wait, this is the one, but it's not taking that. So I can go and I can create one. Wait, I can go to the portal itself. I can show you how it's also being created. I hope this comes up fast. No, bash is good for me. Restart. So yeah, I don't know. Sometimes it doesn't even pop up, man. Is it working? All right, let's not waste time. So what I can do is vote app. Wait, vote app.yaml or something I had written. But what I can also do is I think kubectl will apply myself. That is also fine for me. But let's go and work with it. So this is the one. So what I did was very simple. So I connected that cluster. Then I went to the CD. Then I'll connect the cluster here. So you can see that AKS demo Prometheus Vishwas. So now it's connecting with me and uh, get pods minus and monitoring. Caps lock on. Very bad. No. So if I do monitoring, it will be there. If I do monitoring one, there will be only 4 clusters, get pods minus n monitoring. Oh, sorry. Get ns. If I do get ns, it will show me monitoring one. It doesn't belong there. So I didn't deploy any of it. So there is none of it written. So that's there. So monitoring, get cluster ns, that's fine. So what I can do is there is something called as port forwarding. So this is the one command. So let's just do this and let's just keep this as get pods minus n monitoring. So what I really want is I want to run this application through deployment. So whatever I want to do is I want to do that. So what I did was very simple. Kubectl apply minus f Prometheus deployment.yaml. It's already being created, but if it doesn't, so it's always there. So resource of deployment is missing kubectl.io last configuration. Okay, fine. That doesn't matter. So what you can do, oh, man, sorry. What you can do is you can just copy that and let's just do this. Oh, since I did kubectl port forward, and I want to monitor that deployment on this cluster. So what I do is I do this, and there are different cluster which has already deployed, but I want this to be tested out right now. So what I do is I go here and just type in. So all the commands that I've given is still the same. Oh, it's already there. So perfect. 8020. Yes, it will be working right now. 8020. So if I do refresh, so let me just do one thing. So Prometheus build info, it doesn't have any sort of thing. But when you go for a tables, it says me that, okay, this is what your IP of the cluster looks like. This is what your Kubernetes namespace, which I deployed, was monitoring. If I do monitoring one or monitoring two, it will still give me the same one. So let's just go and type in another command as well. So where are you? So yes, perfect. So whatever it's showing here is here itself. So all the graphs that you are seeing here is a value one. A Prometheus node exporter is what we talked here, right? So whatever you're talking regarding this jobs and exporters is being talked here as well. So that is for cool. And I need one more command from here itself. So rate of it. Think yes, it gave me a lot. What it's just saying is okay, there is a node network. Your Kubernetes networking is one more concept which takes a lot of time. So what it's saying is there is a node, there's a network. What are the number of received bytes total? And now you have a graph. And if you are so much addicted into what your graph might look like, what is this, what is that, alerts are here. So high pod memory is one active pod is already running. If you make 10 replica sets, there'll be 100 pods or anything. It's all about you. So CVRD will go to Slack. If you want to really go to Slack, you can just get it, but it's no brainer. We are just doing it on an local deployment, so it's not a big deal. So if you go for the classic UI, it still gives you the same old command here as well. So all your commands, what you are doing is to execute here. Oh, fine, fine, fine. There will be an other sort of an issue which will be there. So let's not worry about that. And I think there are zero inactivity, there's zero funding, there is one firing. That means perfect. We have an entire infrastructure which is firing at its running to its peak. And if you go for this, not help. You go for this Prometheus, go for this. You type in TSDB status, it says you all the secrets. There are 63 secrets which are there. There are IDs which are communicating. There are 89 mount points. There is a lot of other devices which are also being interacted. Like something like, okay, I have a lot of other namespaces, a lot of other containers. Who what next? So container ID is 33 and lot of it. So TSDB, it's what all about the storage system which is always there. And if you go for this rules targets, you can think of like, okay, what is that? So which is up and which is down. So cube state matrices, cube system, it's already down. So why is it? So if you go here, of course this is down. And if you go for this Kubernetes thing, it doesn't reach, but it's already working. And it's saying me Kubernetes IO instance started DS3. Oh man, this has a lot of matrices to be considered. So whichever the services which are up, which are down, and this is the internal cluster which is communicating inside your Kubernetes cluster. So that's where it takes time, but it doesn't reach there because Kubernetes is completely secure. But sometimes when you see hacker one Kubernetes, it doesn't feel that you are more secure at any given point. So doesn't make sense to a complete extent because a lot of times you have a lot of other things to also be considered. I think I can show you this as well. So let's just go not for the targets, but for the regular application. Well, so we'll pass this query. Perfect. This is the query which is here. I think one more was missing. One more is missing. Actually, since if I had run the same old Prometheus one for a longer time, what you saw earlier was this kind of a graph that you're looking. So I ran it for a very long time, and this is what your divergence looks like. So there is a lot of ups and downs in the graph, and that means like okay, there is some sort of an interaction which is going on happening. And let me just do this. So if I take a look at this complete instance, so there is a series of application that is running right here in front of you. So if you look at all these, so there is an instance type which we are talking here. There is an heritage of Helm that we are talking here. So what I am talking here is still the Helm, which is always configuring the charts, which is always looking for what my container and what my clusters are looking like and things like that. So there's a Prometheus node chart, which is still having an access to the Grafana API, which we are talking about. So PromQL is still taking the same old Grafana thing and it's just throwing it out. So let's just go to this demo of this entire thing, because a lot of times that namespace is already not taken into consideration. So let's just do the same old thing what AKS has offered. AKS Kubernetes, AKS documentation, CLI. So let me just do that itself on the local system because it's on the local system itself. So let me just grab that YAML file. Azure oat.yaml, yeah. So it's still an Azure oat.yaml. So yes. What's the name of it? Let's just copy that. Why to make it even more complex? Should never be a plain text, all file types. Perfect. It got added. And if I do Control C and I do the dir, it still works the same way. So let's just do that. So let's just do dir Azure root.yaml. Perfect. So I think if I do get ns kubectl get ns, there are namespaces which I did 12 minutes ago. So perfect. What I do is simple as that. I will go to this entire apply minus f minus n monitoring 1. So your kubectl apply and deployments will be taken place there. And now if I do kubectl get deployments, get services minus n monitoring 1, kubectl CTLE. Oh, sorry for that. Get not bad. Get services minus namespace monitoring 1. Get pods. So Azure Wood is running. So there is, what did I miss out? Okay, okay. So this will be an external IP. If you want, you can even do that. But whatever I'm saying here is something like this isn't global application. Like it just get deployed and things like that. But if I do the same thing or get services, the IP will be different. You can see that because there is already an app which is there. So see the difference. There is an correlation with whatever we are doing. Like it's actually behaving as what kubectl is, and it's not. And this is how your namespace is different. And you can see the same namespaces in the Docker as well. It's just like some virtual environment which is created, which separates all your application from one application to the other. And that's it. What you are seeing here as a namespace, wait, I'll even show you. What is this namespace, instance, heritage, Kubernetes name, what not? It still uses the same, but where is it? I think this should have been gone with respect to cos 8020. I hope it's not working. Now the graph will be different. Now when you do the same command, see, now there is a change in the graph because we have run the same old cluster for a longer time, and there is a huge instance. So I'll say you Prometheus engine query, so config, reload successful, build information, that's fine. So when you do for this table, you can see the namespace is monitoring 1. So if you do the same old thing for the kubectl apply minus f, kubectl apply minus f, Prometheus deployment.yaml, where is this minus n, monitoring 1, oh, since I have to change that one also there, so oh my god, it takes a lot of other places to be also changed. So let's not check it, but let's just adhere to the fact that it happens because a lot of times when you are looking at all these kind of applications, there are hundreds of places where you are supposed to change. Not hundreds, but tens and places, but it's already time and we are supposed to move the session also. So whatever you saw today is an entire application which is just built in order to give you that one thought about like, hey, what if my application goes down at one given point and what to be fetched and what should not be fetched. And that is what we are talking today all about. Oh, sorry, it's not working because it will now start working. 80/20, perfect, it's communicating. So see, now the exact way in which your graph was there, it's just there, and you're just monitoring all the clusters which are there here. So in a bigger scale, this is not the same old graph that you will look, probably will look something like, let me just do control 2, it will look something like this, like this, like this, or something like there is an up and down, and there is always this down, 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 down situation. And that's the point where you have to think like, what is wrong with my system and things like that. So I think that's it, folks, for the session. I think I covered pretty much all what Prometheus can offer because it's a big chunk of a material that we actually wanted to think about. But when you think of deployment at scale, these are some factors which come up and says, hey, this is what we require and this is what it is. So I think thank you so much, folks. I think this is what I wanted to convey. And guys, to send your questions if you have any. It's hello, hello here. Fine. Deepak, done with the session then?
Thanks, Vishwas. Thanks so much. I think the audience has some insights on the Prometheus. Now they can start their journey
It's
on the
too big. I
Prometheus.
can't explain it in a day. Sorry for that.
But they can start their journey. I mean, I
Yeah.
know it's a big topic, but they at least they got some insights from how they can start. Yeah.
Yeah,
So I
yeah.
think that's really good. We all are learning, so it's a great thing to share the insights to get started. Everyone, thank you again. Thank you so much, guys. Thank you so much. Thanks, Vishwas again.
Thanks. Thank you, Deepak.
Yeah.
And the
Have a
broadcast
good
now.
day.